The overall goal of this synthetic protocol is to link colloidal shape-anisotropic semiconductor nanocrystals, facet-to-facet, via an oriented attachment process.
Well, this method can potentially address key issues in the field of colloidal nanoparticle-based optoelectronics, such as the need to improve interparticle charge transport while preserving solution processability. The main advantage of this technique is that the facet-to-facet linking process can be applied to semiconductor nanoparticles of various shapes and sizes. We first had the idea for this method when we observed signs of oriented attachment after carrying out cation exchange reactions in shape-anisotropic semiconductor nanocrystals under certain reaction conditions. Demonstrating the procedure will be Xuanwei and Shashank Gupta, grad students from my laboratory.
First, add topo, cadmium oxide, hexyl phosphonic acid, and octadecyl phosphonic acid to a 50 ml 3-necked round bottom flask. After adding a magnetic stir bar to the mixture, insert a temperature probe through a punctured rubber septum and seal one of the ports of the flask with the septum. Mount a reflux condenser on the round bottom flask and connect it to a Schlenk line via an adapter. Then, seal the remaining port with a rubber septum. After applying high vacuum grease on all glass-to-glass joints, heat the stirring mixture to 150 degrees Celsius and place it under a vacuum for 1.5 hours to degas. Next, add 1.8 milliliters of a previously prepared TOP sulfide stock solution to a 10 milliliter single-necked round bottom flask and seal it with a rubber septum.